Hello and welcome to Slooh, where you lot out there can learn to explore space in a global community of fellow Earthlings. Hello, I'm Paul Cox and this is Slooh, and you're joining me for a great show today. This is going to be a really relaxed show actually because we are broadcasting live from the best office in the entire world. I'm going to make you a bit jealous today, so I warn you of that. But as you can see, there's loads of interesting stuff if you're a bit of a gearhead. Loads of interesting stuff that we're going to talk about later. But the main thing that we are going to be covering today is the sun, and the sun specifically through Slooh's Canary 5 Solar Telescope. So I'm going to tell you all about that a little bit later. But there it is. It is operating. So when you're watching the show live today, on the event page in the Situation Room, you'll see a little tab underneath it, and you can flick to that and you'll see the live views that are coming straight from that telescope straight to your desktop. So it's all pretty cool today. The other reason, of course, that we're doing this little show today is a bit of a test for Slooh's studio over in Connecticut, because part of our Slooh's really exciting, really exciting. I've never been so excited in my entire life as Slooh, and I've been here for 14 years. Is part of our 2019 expansion plans. We've got some new guys over in the studio, so hi Jack and everybody over there. So bear with us. It's first time for some people over in the studio. Plus, I'm sitting on the top of a volcano, a little bit cold, so things might go wrong here. So stay relaxed. We're going to have great fun for the next 30, 40, yeah. I was going to say 30 minutes, but you know me, it's going to be 40 minutes, isn't it? So we are going to look at all of the gear that we've got here. We're going to look specifically at the solar telescope. What makes that so special? We're going to be having a look at the live views, and I'll be explaining some of the solar features that we can see today, but very rarely as well. While I'm explaining that, we're going to be tuning the telescope to actually see different features. So a little bit later on, if it's still there, we saw it this morning, there's a lovely prominence. I'll explain what all of that is later as well. But we'll tune the telescope specifically to look at that. So don't miss that a lot. What else are we looking at? Oh, we got some of the highlights, some of my best highlights and member images that have been captured using the Canary 5 Solar Telescope. But first of all, by the way, I will be answering your questions as well at the end of the show. Now, go over to the Slooh discussion boards, and there's a post there. You'll see it be right at the top. If you've got any questions about this, mainly let's try and keep it about the observatory, the sun, or the Canary 5 Solar Telescope. We'll try and keep it around that. But post them in there, and that's what we'll answer at the end of the day. And don't forget, we've also got news of a very exciting show that we've got live from the observatory, which is in live 360-degree video, where you are going to be able to point in the video itself where you want to have a look at. So we're going to do a virtual tour of the observatory. But first of all, let's set a little bit of context. So I've told you I'm at Slooh's Canary Islands Observatory. It's our flagship observatory at the Institute of Astrophysics. But where is that? We've got some great images that we're going to show you. These are live images from some of the cams that we've got. But the Canary Islands is basically a volcanic chain of islands, which is a couple hundred miles off the west coast of Africa. Very similar to a lot of other volcanic chains like the Hawaiian group and stuff like that. But we've got a couple of images that we might be able to put up which show you the view from the very top of what's called Pico del Teide, which is the highest volcanic cone, which is about nearly 9,000 feet, over 2,500 meters. The observatory where I am now, we're at 8,000 feet, so that's a little over 2,000 meters. So we are going to have a couple of very short 30-second breaks during this show, and that's mainly for me to kind of take on some oxygen up here, because it really does. You walk up a small flight of stairs and you get really puffed out. But we'll have a look at those images when we can. But in the meantime, I will lift up. Oh, there's our live dome cam. So you can see there, I'm just taking a look at this. So I'm actually in that image. I'm kind of the blur in the middle of that. But we've got this, you can see the Slooh Solar Telescope off to the left. That's the little white one. You can see the gold shrouded one is because I've got the dome open and we're protecting the Canary 3 Deep Sky Telescope. So that's the one that we're going to be working on tonight, because what I'm going to show you with my webcam, if we go back full screen with my webcam studio, I will give you a lovely little panorama shot around the observatory. In fact, I've just got to get rid of a headset as well. So let me just open up. I'm going to open up this side of the dome, if you can see. Oh, there we go. So excuse the handheld. Oh, isn't that horrible noisy? That's the noise the dome makes. So I've told you this is the best office in the world, right? Well, take a look at my view out there. That's pretty cool, isn't it? So 8,000 feet up, we're looking down onto the Atlantic Ocean. You can just see there's a kind of hump over there on the horizon. That's the neighboring island of Gran Canaria, which is basically just one enormous volcanic cone. And then we can pan around. So we're going south now. Let me just point this down. Sorry, I'm trying to look through the sunlight as well. There's a little higher car panning around further and further. This will give you a good idea actually of how big these domes are. So that's an average little family car. And over here we've got Dome 1. That's where the mighty Canary 1.5 meter is. I don't know who that chap is down there. We might introduce him maybe on Saturday's live tour. So I am not single-handed today. And then over there, you can see Dome 2. That houses the Canary 2 17-inch telescope. And we also have an ultra-wide field there as well. Right over there on the horizon, I don't know if you can see that. That's the residence. That's where the astronomers and we stay when we're here. Because I'm actually here, we're installing some new telescopes and also doing lots of maintenance, stuff like that. That funny stuff up there that you can see up there, sorry, I've got a bit of a time lag, is a lightning rod because we get some big lightning shocks. And then up there, right on the horizon, you can see some of the largest solar telescopes in the world. And then I'm just, excuse me, I'm just trying not to bang any telescopes while I'm here. Further around, you can see that's our dome cam there. So we're looking at the dome cam, looking back at me, and we see the weather station then right off in the distance. So we're now pointing kind of northeastish, something like that. That's a big meteorological center up there. And then we're back down to where we started. So if you have, I challenge you, if you have a better office view than I have when I'm at the observatory, then I challenge you to share it with us. That's a little solar telescope. Give you a close-up view of that we're going to be talking about in more detail a little bit later. So I reckon we should take a quick look at the live views. Oh, look, there's a picture of me looking at you, looking at everybody else. This is kind of this infinity stuff, isn't it? Oh, I'm going to get a nice suntan, aren't I? In fact, I am just going to excuse me, I'm just going to close the dome a little bit. Anybody who doesn't like the sound of scraping fingernails on a blackboard would not enjoy working here. So what are we seeing? Here we've got the live views direct from the Canary 5 Solar Telescope. Now, we can see quite a lot of granulation. That's all the kind of little flecks of darkness on there. We are going to take a look at the actual features that we can see today a little bit later. But first of all, I want to tell you why the Slooh Solar Telescope is so special. So you've seen it there. I've shown it to you there in the webcam. Oh, there it is. Oh, good one, studio. So there is a photo that I prepared earlier. Well, it kind of looks like a normal telescope. If you see the white bit at the top, we've got another image of this actually, which is on the side. And it looks really like a normal little telescope. But the thing is, this telescope can only view the sun. There we go. It's a great view there. So it kind of on the outside looks like a normal little refracting telescope. That's the kind of telescope you'd expect, you'd think of if you were talking about I Spy, something like that. But what's going on inside this thing to make it so special? Well, you can see all that gubbins in there in cross section. Those are the special filters that cut down the enormous amount of light reaching us from the sun. If you pointed a normal telescope at the sun, you would frankly fry it. So where all the light is focused at the back of it, hopefully not when you're looking through it, you would fry anything. It would melt the glass. It would melt everything at the back of the telescope. So one of the primary things that a solar telescope like this one is trying to do is reduce the amount of light reaching either the eyepiece or, in our case, a high frame rate video camera. And it does that by, you can see it's labeled here. It's called an etalon. And really it is, there's lots of complex stuff in there, but an etalon is basically two pieces of optics, so two optical layers. And what they're doing is the light comes in and they have reflective surfaces inside. So what happens is a lot of the light just gets reflected between those two pieces of optical glass and filter. So a lot of that light gets stopped right there. And what happens is a solar telescope like this is tuned to only allow a certain frequency, a certain bandwidth of light to pass through. And in this particular case, we're looking at the light which the sun is emitting from excited hydrogen particles. So that's what we're seeing. We're seeing the upper layer of the sun's surface, and we're seeing the light that's being emitted, the photons that are coming away from excited hydrogen atoms. Now, at the back of this telescope, you can see there's another fun little bit as well that kind of goes at 45 degrees. Well, that's an um, energy reflecting filter. So that reduces even more of the light, which is reaching either the eyepiece or the camera. So this is why it's so special that we're only seeing this very, very narrow bandwidth of light being emitted from the sun. But what we can do is if we can change the distance between those two optical surfaces, we can change the frequency of light that we're seeing. So why would we want to do that? Well, that's what we're going to look at a little bit later when we actually change that tuning live. But I will just show you one thing in my webcam at the moment. In fact, let's go back, studio. Could we go back to the picture, the photo of this, the solar telescope, because you can see this far, far better. What we actually do is that big white box on the back of it is actually an air pump, an incredibly precise air pump. And we pump air between those two optical surfaces, and it just pushes them out very slightly. And that's sufficient to highly tune what features we can see. We're also going to change the exposure of the high frame rate video camera later so that we can also see different features. So anyway, that's kind of what makes that particular telescope special. But I'm just going to take another look now, see what else we're going to move on to. So right, now then, if you are looking at the live view, so don't forget, if you're watching the live view, if you go down to the tab on below the main video of the show, the live show, you'll see that there's Canary Islands, sorry, Canary 5 Solar Telescope. If you click on that, you'll be able to see the live view. Otherwise, you can see it on the board. But here we've got another image. And in fact, we've got a great graphic here. If the studio can pull up the Solarscope screen grab, because I wanted to explain to you what all of the different elements are. When you're watching this live, there should be a full screen one there, studio, if you can pull that up for us. Might be annotated as well. So you'll see all of these other features. Here we go. This is the one. So first of all, what we can see is, so all of the blue annotation is stuff that we've added over the top to explain what you're seeing in the live view. Let's start top left-hand corner. And we can see that all around the Solarscope live stream are little ticks. And those tick marks are actually marking actual angular size. So angular size is basically, think about the field of view that we're seeing, and the sun is fitting in that across the entire screen. So you can see that those are marked in arc minutes and arc seconds, right? So that's what those mean. So in fact, at the moment, I believe, I might be wrong on this because I didn't look it up before the show. Earth is currently, in fact, I'll ask my assistant, is Earth currently far away from the sun? So we think at the moment in Earth's elliptical orbit, the Earth is actually quite a long way away from the sun. It might be around the other way. It might be that we're close at the moment. But in either case, at perihelion and helion, or aphelion, and forgotten the terminology. When we're closest to the sun, in our view, the sun looks far bigger. But when Earth is further away in its orbit, the sun looks smaller. And you can actually measure that by using those tick marks at different times of the year in any of the images that you snap. And there you go. Actually, I've got it. Look, this was clever, wasn't it? This is one I definitely prepared. Right in the center of the screen is what I'm actually talking about, the apparent diameter of the sun in this feed. So at perihelion, when Earth is closest to the sun, it's 32 minutes wide. So those minutes I can't quite see on this diagram because it cut off for me. but those are, I think, the larger ticks. And then a aphelion, when Earth is furthest away from the sun, which I think is now, it might be that now, it's 1 arc minute less. All right, so you can actually measure the changing size of the sun as Earth is going around. Anyway, we've also got, we've switched them off today, so you can't see them in the live feed today, just because we've been working, we've been getting in the way. But at bottom right, bottom left, or bottom or top right, top left, you'll see 2 webcam views, and these are showing the interior view of, and they're always directed towards the telescope, so you can actually see the telescope while it's in operation. You've also got some other little features here. So bottom right here can sometimes be at the top, depending on which part of the sun we're looking at. But you can see the live time there, that's clicking away. You can also see exactly where the telescope is pointing, so where the sun is in relation to this. Now, if you looked at it at the moment, I can't see it on my screen at the moment. In fact, I can probably find it. Just looking at my machine. Do bear with us because we're trying to do lots of things today. The sun at the moment is only 23 degrees above the horizon. So as you can see in my webcam here, you can see how low it's pointing. And of course, at this time of year, you know, the sun remains very low for the northern hemisphere. So it's not the best time of year to view the sun, but hey, listen, we're still at 8,000 feet above all of that atmosphere, so we still get some pretty good views. So we've got the telescope coordinates, and excuse me, there's something else on there that I can't actually see, unfortunately. Let me just have a look. No, I can't see it on my screen, I'm afraid. But anyway, there is an illuminations post that you can go to on the website, which has this image, and it also has far better descriptions than I've probably given there in that post as well. So you can go away and have a look at that. But it would certainly be worthwhile. I'm just going to move the solar telescope actually, because it's drifting out of view a little bit. It might be a kind of 30-second lag before you see that. But why don't you try taking a snap around now, when the sun's apparent size is, excuse me, either the smallest it can be or the largest it can be. I can't remember which way around it is. But then in 6 months' time, compare that to another snap then, and you'll see just how much the sun has grown or reduced in Earth's elliptical orbit. So anyway, we've got all of that. So that's pretty cool. What else are we going to go to? Well, I'm going to tell you what we've got coming up, because as you can hear, Cox needs some oxygen and maybe a drink of water. But don't go anywhere, because coming up, what we're going to do is we're going to be taking, after a short break, and I get on my oxygen tank, we are going to take a look at the features that we can see in the live feeds today, and might have to do a little bit of retuning to see those. We'll also be taking a quick look at the other solar features that we can sometimes see that aren't necessarily around at the moment, as well as some of my favorite images and time-lapse animations. And there's some corkers of that as well that members have snapped from the Slooh Solar Telescope. And of course, I'm going to be answering any questions that you've got that you post in the discussion boards at the end of the show. So don't go anywhere. If all goes according to plan, we're going to be right back after this short break. See you in a couple of minutes. Hello and welcome back to Slooh, a worldwide community where we all learn to explore space together. And today we're taking a close look around the best office in the world. I'm at the Slooh's flagship observatory in the Canary Islands at the Institute of Astrophysics of the Canary Islands, and we are taking a live look at the sun, and that's what we're looking at right now through this great live stream. And while we're looking at the live stream, just to remind you folks, I'm in the dome where that telescope is. And there is the very telescope which is providing us with these stunning live feeds. So let's just remind ourselves, maybe, what part of the sun we're looking at, because we kind of went into it a little bit. But we got this. Oh, look at that studio! Oh, ahead of me. You guys are rocking it today. Now, listen. When we normally see, if you've got a pair of eclipse glasses or something like that, or actually, even if you accidentally glimpse the sun, so if I just accidentally glimpse the sun now, the surface of the sun, the layer of the sun that we're looking at when we do that, do excuse me, I'll maybe move my webcam so I'm actually looking more towards you rather than the screen. We're looking at the layer of the sun called the photosphere when we do that. And that's where you'd see kind of dark sunspots and stuff like that. But we're looking at the layer outside of that, the layer above that, in those excited, the light being emitted from those excited hydrogen atoms that I was telling you about. So the surface that we're looking at in the live feed state is called the chromosphere. And some of the other features actually that we can see here. In fact, let's do this slightly around the other way while we've got this diagram here, because we'll then go in the hunt. We'll go on the hunt for some of the features that this diagram showing. So we're not going to see sunspots because the sunspots are below, they're beneath the layer that we're seeing in the live feed today. But we've got some flares there. So we might be able to see some flares when we tune the camera a little bit. Go over onto the left-hand side of this diagram, and you'll see something called a prominence. Now, we are definitely going to see a prominence, so don't go anywhere. We're going to have to tune the telescope and the camera to be able to see that. But that basically is a huge plume of excited plasma, hot, super hot gas, which is being blasted off the surface of the sun. And sometimes when those detach, they can actually make a coronal flare or coronal mass ejection of high energy particles that bombard Earth, our communications satellites. They actually increase, they heat up our atmosphere when that happens. So our atmosphere actually expands, which means that all of the guys who are managing their satellites, their communication satellites, the International Space Station, all of those low Earth satellites, they usually have to use some of their fuel to boost them up because they get dragged in this expanded atmosphere. So let's take a live look. Now you're going to have to excuse me because I'm going to be controlling the telescope as we go along. And let's just first of all, let's see what kind of time skip we've got. So in the first instance, I'm just going to move the telescope. So I'm just about to move it now. I'm going to move it up to the top. And we'll see maybe could be 10-20 seconds time lag between what I'm doing and what you're seeing. So I've just slewed the telescope so that we see the top of the sun. You'll see that in a second. Now let's have a look. I am now, if you remember at the beginning, when I was explaining how this telescope works, we were talking about those two optical surfaces, right? And the distance between them changes what features we can see. And the way we're going to do that is we're going to, gosh, this looks like I'm praying. That would be a first, wouldn't it? We're going to pump in air between those two optical surfaces. There you go. You just caught up with me. To just slightly change the spacing. And we're talking about microns. We're talking about tiny, tiny distances that we adjust this thing. But it means that it tunes into a different bandwidth of light, and different features on the sun emit different bandwidths of light. So we've done that. So we've moved into the zone. Now I'm just going to increase the pressure between those two pieces, those two optical elements, which is forcing them apart, which actually means the sun's going to get a little bit darker, which means I then have to go over and adjust the exposure of the camera. And you're going to see this in a little bit of a time delay. So apologies for that if it doesn't make too much sense. But let's go on the hunt to see if we can find any what are called active excuse me, uh, any active region. So what we're looking for here now is, you will catch up with me. Um, there's no other way of us doing this, I'm afraid. So we'll have to live with the time delay, but you will see what I'm talking about in the end. So, so we've changed the there we go. Oh, you can see it going in there. We've changed that. And now we're going to change the exposure of the camera as well. And then we're going to hunt over the surface of the chromosphere to see if we can see any active regions or flares. So let's just move this up. I can't see anything on, excuse me, on the top of the sun where we're looking there. So we'll move the telescope down, and right, you're going to be able to see this far, far better in high resolution when you're watching the show or the live feed. Near just left of center of the sun, there's a small area where all of those black granularly bits kind of look like they take on more structure. Will come into view in a second. Snap an image of that, because the snapped image will often show far greater clarity of some of these features than the actual live video. So there we go, we're slowing down. So just left of center where you're seeing, when it stops, have a look and you'll see a slightly more dense area. Now, we might be able to pull some of that detail out a bit better. So I'm going to change the tuning again. So we're going to move the tuning down. So this is releasing the pressure. So these two optical surfaces of this special Etalon filter are actually now moving, they're moving closer together. So we're going to see features in a different bandwidth. So you'll catch up with me on that. I'm just going to change the exposure of the camera again, and we'll go on the hunt in this different bandwidth, because that's what we're doing. We're looking at a different bandwidth of light than we were a minute ago. So let's have a look. And then immediately after we've done this, we are going to go on the hunt for a solar flare. And they are pretty cool. We've seen some great ones. I've got some great ones actually to show you a little bit later. Some great examples of that. So while you're looking at, oh, hold on a sec, come back, son. While you're looking at those changes, so there we go. I've changed the distance. So we're now looking, actually, what we're doing really, we're tuning the telescope. So we're looking at a different layer of the sun. And in fact, at the end of this, we might actually look at the photosphere, because if we reduce the pressure to zero, so these two optical surfaces are just normal, we're actually seeing the photosphere. But now we're going to go on the hunt for a flare. So take a look, snap any pictures and share them in discussions. If you can actually, I'm looking at kind of lots of different screens, and I'm not seeing stuff at the full quality that you are. So you might be able to spot some of these features a little bit better than me. But now we are going to go on the hunt for a solar flare. So we are going to increase dramatically the exposure of the high frame rate video camera. We're still going to be tuned to roughly the same level. Excuse me. Right, let's take a look. Oh, okay. You're in for a treat, folks. You are in for a treat. So, given the all this electronic stuff, is meant to move at the speed of light, isn't it? But it has got to move across 3,000 miles, get processed by servers, and then come back. But we have got a really cute little prominence. So let's have a look. There you go. I'm changing the exposure of the camera, and immediately you can see just at the very top of the screen. Don't worry, I moved the telescope down in a sec so you can see this even better. We can see a prominence. So quite often, and we'll see this later on in some of my favorite snaps from this telescope, we see these active regions. So these are regions which have basically got the magnetic field lines of the sun. And don't forget, the magnetosphere of the sun reaches out, extends out to Jupiter almost. It's utterly enormous. It's the largest object in the solar system. It's absolutely enormous. So it actually affects all of the other planets. Oh, the studio are on fire today. Look at that. They've even managed to zoom in on that prominence. Now, we can do some fine tuning of this. And don't forget, we are very, very low now. We're about 20 degrees above the horizon. So this is really not the best time to view this. But what we can see there is the very hot prominence of plasma. This is superheated gas plasma, which has thrown off electrons in all in all manner of ways, and is spewing out from the sun. So this active region that we sometimes see is where the magnetic field lines break free of the sun and they kind of loop back. And what you'll normally do if you see a sunspot, you don't normally see a single sunspot. Sunspots normally occur in pairs. And one spot is where the magnetic field lines are coming out of the sun, and the other sunspot is where the magnetic field line loops over and comes back in. So what we often see when we see filaments, which we'll see some great examples of later, those are just these things, these prominences that come off the edge of the sun when we see them on the surface. So there is some other fine tuning, but I'm just going to make sure that we don't miss any other flares that may be there. So I'm going to slew the telescope, move the telescope up so that we can see down the bottom, the southern part of the sun, just to see if we can see any flares down there, because there was a small one there this morning. And these features, of course, change very, very rapidly. We see them, oh, we got another good one. They change over a matter of minutes, let alone hours or days. But this is a nice one as well. So this one's going to come into view. I need to change the exposure level because this one is going to be too bright otherwise, because it burns out a little bit. Oh, the machine's doing something, so I have to wait for that to finish. Yes, okay, thank you, machine. Thank you for being so helpful. Great job, by the way, studio over in Connecticut. And there you can see this other huge prominence. This is massive. So if we talk about the size of this thing, right? Well, wait for it to stop moving. And there it is. And I've just tuned it up a bit, so we'll see it when it's not so blown out. You can imagine that you see the two bright blobs there. Each one of those is the size of the Earth. So that entire prominence, you could probably fit 10 Earths in. I'm always gobsmacked at the size of some of these solar features that we see in the telescope. We've seen some that would fit 30 Earths inside them. Yeah? So those are some of the ones that we can see live today. So we'll leave that to one side so you can keep snapping away at this, because even over there, we've probably got another, what's the time? We've got about another half an hour before the sun sets locally here at the observatory. I'll tune it up when we finish the show so that we get this as crisp as it can possibly be. But keep snapping images and you'll be able to see how that prominence, how that huge, massive plasma is moving at probably supersonic speeds or near to it, across the surface. I'm just looking at it now, so I want to take a snap of that now. But look, I've got my hands full. I'm doing other things. I'm entertaining you guys. Now, what else are we going to have a look at? Those are what we can see today. But what are some of the other features that we can sometimes see? Some of that I've spoken about there. We've got some of my favorite snaps from members. So look at this one. This, first of all, actually is from another Illuminations post. So if you want help identifying solar features, have a look at the Illuminations post, because this diagram is in it. And I've highlighted here, excuse me, all of the different kind of features that we can normally see when they're visible. So first of all, you can see I've got active regions there, and those are normally marked by those turbulent areas where you can see lots of twisting dark stuff, normally in a single place. You'll often have filaments, that dark thing that looks like a dark cloud, coming off from an active region. We can also see that there's a tiny sunspot. The sunspot truly is underneath the active region, but in this particular example, we even get to see some of the sunspot in the chromosphere where we're looking. But we can also see, excuse me, this very bright area that is marked there as a plage. Now, plage is French for beach, and they're always really easy to spot. You can see there's another one in this particular snap, just right of center. You can see on the left. So think about, we've got that active region. See the filament, this huge stream of superheated plasma, and that's arching above the sun. But when we see it against the face of the sun, we see it like that, a dark cloud. But as the sun rotates, all these things, these features move to the limb of the sun. They're called prominence. So a prominence and a filament is exactly the same feature. It's just where we're seeing it, whether or not we're seeing it silhouetted on the limb of the sun when it's a prominence, or if we're seeing it on the face of the sun when it's a filament. But let's hop through. We'll go through these quite quickly, but these are some of my favorite images, remember. So that there we can see that one. Look at that. Look at that active region there. And this is showing, actually, this is one of my favorites because this is the difference, a little animation I made of two snaps I took from the Canary Solar Telescope 9 days apart. Look how much the activity, the solar activity, has changed over a period of just 5 days. So there we've got that huge active region with this huge stream of plasma and filaments coming off it. And then suddenly, 9 days later, it's as quiet as anything. So let's skip through some of these other ones, Studio, if you wouldn't mind. Let's see what else I've got. So there's just another one of this incredibly, it's a bit distorted. The sun is not really that shape, but well, still looks quite cool, doesn't it? Kind of egg-shaped sun. I bet you there are stars, that are that shape, that are spinning so fast that they become that kind of egg shape. Do you know Jupiter's not a sphere? It's one I've told you before, but it's one of my favorite astronomical terms. The shape of Jupiter is no oblate spheroid. I always say it sounds like it's something you should go and see your doctor about. Excuse me, doctor, but I'm suffering from very bad oblate spheroids. But it's because Jupiter is spinning so fast, 9 hours, 56 minutes on its axis, that actually it can't be a sphere. It kind of bulges out at the equator. But anyway, the sun is not really like that. But look at that huge active region. Let's hop through these other ones, Studio, and as you bring them up on the screen, I'll point anything out that we should look. Oh, now this one. This is a great one. This is just as I was starting up the solar telescope one day. It was very low on the horizon. We caught this satellite, that whizzing thing, that black line that you see whizzing through the telescope, whizzing over the face of the sun, is actually an artificial communications satellite. And quite often, not here so much, but a lot of solar observers will often see aircraft or even the International Space Station passing in front of the sun. We don't get aircraft here because aircraft aren't allowed to fly above the observatories in the Canary Islands because it's protected airspace, because astronomers don't want aircraft and other stuff whizzing through their fields of view and spoiling their observation. So let's take a look at the next ones we've got here. That was just this was just such an extraordinary amount of activity. This, I think, was from 2017 when we went through a very, very active region. We're actually at what's called solar minimum now, so we're not seeing very much activity. But this one is an absolutely classic example of these bipolar active regions. So that huge area to the left, you can see two black spots on it. That is where the huge magnetic field lines are coming out from the surface of the sun and then going back in. And if you look at this image carefully, remember that physics experiment that you did at school with a bar magnet and sprinkling some iron filings on the top. That's exactly the structure that we're seeing, emanating this kind of bow shape coming from this active region, because it's exactly the same principle. All of that hot gas and plasma and all those atoms are being sculpted by that huge magnetic field line that's coming out. Let's take a look at the next. So some of these are cracking. And I don't know about anybody else, but I've built up a terrific collection of snaps in the solar telescope. Now, this is another little favorite of mine. This was a huge prominence. This is the mid last year. What's the date? I can't quite say it, in 08. But this was tracked. So this was over a period of about 5 hours. I kept taking snaps all the time from the solar telescope views to turn into this time lapse. So I then stack them all on top of each other and turn them into a movie. That is not the real Earth, by the way. That Earth is not that close to the sun. That's just there to show you the scale of this enormous prominence. But what we can see here is the magnetic field lines there, and we can see the plasma flowing along them. I just love this. So this is what you can see on a good day through the Slooh Solar Telescope. Bit quiet today. We've got those couple of small prominences, but this is why it's worthwhile checking this telescope every single day, because there is always something new to see. Look at this one. These were just some of the best defined prominences I've ever seen. And they were really peculiar because the one at the bottom, that's actually called a pillar prominence. And it probably does loop back. It probably is a loop, but we're probably seeing it end on. The one at the top, that one was kind of almost two prominences that look joined together by this strange zigzag of plasma between them. And I'm still not certain whether or not that was two separate prominences with just some background plasma in there, or whether or not it was actually some kind of arc that had broken. So let's take a look at some of the final images on here. Excuse me, guys. That's just another example from 2017. Now, sometimes this is a great example. Sometimes I like to actually take a screenshot. I put the Slooh Canary Island feed full screen and take a snapshot of the entire thing, because that means you can see those two webcam views up there. We've got in this snap all of the the distance markers on the edge of the screen. It's already got the time in there. It's got the exact location, the coordinates of where the sun was, and it's also got that little Earth scale thing as well, which always looks quite good. How many more of these have we got to go, studio? Oh, that was a nice hedge prominence. We got about 3 more of these to go before we move on to the next segment. Now, this one I got really excited about it because this is the first time I had seen what's called a hedge prominence, and you can kind of see why it's called a hedge prominence. We're not seeing a single loop of plasma. We're not seeing pillars of plasma coming up. We're actually seeing this is kind of like a one of those curtain eruptions in Iceland. You know, when you get a curtain of lava just flowing up, that's the equivalent of this. It's a hedge prominence. It's just this wall of prominence that we're seeing on the limb of the sun. And I've popped in there. It's always good. I always think if you're sharing one of these images with anybody else, give people an idea of the scale, the vastness of some of these things. So I've just popped that little Earth scale on there. How many Earths do you reckon you could fit in that? Must be 50 maybe. And this is one of the last, we've got 2 more, I think. This was by David Malik. Now, David Malik first posted in discussion boards his solar system family tree, and it had all of the planets in there, and you can see brilliant captures. All of these were Venus, Mars there looking brilliant, because 2018 was a really good year for Mars. Got Jupiter, that little black dot on there is actually the shadow of one of the moons passing in front, so David managed to capture that. We've got the great red spot there. Saturn looking brilliant last year because it's tilted fully towards Earth, so we can see all of its rings. And then we got Uranus and Neptune with all of its moons. But I said to David, hey David, you snapped some great images from the Canary 5 Solar Telescope this year. How about putting that in as well? So he's just managed to put in one little bit of it. But what's interesting here is David has kind of presented this in their apparent size. But it's a lovely little family portrait, isn't it, of the solar system. So let's take a look. We got one more image, I think, one more of my favorite. This is the last one. It better be a good one. Okay, so this is just explaining to you uh, why actually today and this time of year is not the best time to go solar observing, even though we've seen some pretty darn good snaps from that camera over the last couple of months. But here we've got, this is the view from our all sky camera. So regular Slooh members will know that we have these all sky cameras that operate during the day and at night. And what we can see here, this is at the same time every day. So it's at midday, halfway through the day, every day, at March equinox, June solstice, September equinox, and December solstice. So we're just beyond December solstice, and you can see that's when the sun is so low in the sky here. We almost have to open the dome that I'm in completely for the solar telescope to be able to see the sun when it's low down. So why is that important when we're solar observing? Well, think about the June solstice there, when at midday the sun's right above the solar telescope. We're looking through a tiny amount of the Earth's atmosphere. But look at December solstice, where we're not far off now, and we're having to. The telescope is not horizontal, but it's pointing about 30 degrees above the horizon. We're looking through so much more atmosphere, and that disturbs the image that we get. And quite often, we noticed it today actually when we started up the solar telescope. The sun was shaking and rocking and rolling, and that was because when we started up, we were looking through loads of atmosphere, and the atmosphere was turbulent. And that's what we normally refer to as the seeing conditions. And you'll see that when you watch the live telescope views at night. But anyway, listen, we've looked at some of the live features. I'm still looking in the live feed. That prominence is still burning strong, and we'll see that all the way through until the sun sets behind the local bushes, which I'm just taking a quick peek at them. I'll show you in a sec. We'll go full screen on my webcam, and I'll give you one last little look around the sky. But we're not going to go studio. Oh, excuse me, I just lost something on my screen. Studio, would we like to go to a break, or shall we persevere and finish off? Okay, so after this short break, I'm going to tell you what we've got coming up in at Slooh, some exciting little things coming up, and I'll also give you one last view to make you jealous of the best office space in the world. And I'll also, during this break, take a look in discussions, see if there are any questions for me there. We'll be right back after this short break. Bye for now.
To announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com.
Hello and welcome back to Slooh. We can learn explore space for the worldwide community of other members. We've been looking at live views of the sun today with this is all part of our expansion plans actually for 2019. We've got some new studio staff over there in Connecticut at HQ. So great work over there, guys. And I'm reporting live from Slooh's flagship observatory at the Institute of Astrophysics of the Canary Islands. Now, Carol has posted a couple of great snaps. Carol Botha from South Africa. She's posted some great snaps over in the discussion board. So take a look at those later. If I know it's been a bit weird timing this show for a lot of members. So if you have got any questions on anything that we've covered today, then post them in the discussion boards and I'll answer those over there. And don't forget, if you do miss any Slooh show, you can watch them all. You can watch all of our live casts again. Look at this live view just to put where I am in context. Does that make you jealous? So this is Pico del Teidecam, about 9,000, 10,000 feet altitude, and just on the ridge. So what we can see there, what we're doing is we're looking down into the huge caldera. That's the collapsed floor of the volcano, the main volcano on the islands. But go along the top of the ridge and you'll just see some little white markings. Now, if you're displaying this in full high def, then you'll be able to see that that is the observatory. So that's where I am. We'll zoom in and zoom in however the studio want to do this, and until we come back to my live view, and I'll give you one last 360-degree tour around the view here. So let me just open up the dome in preparation for that. So lifting up my little webcam, so it might be a bit dodgy, but there we can see the Slooh telescope, the thing that we've been looking at these brilliant live feeds through, and we can see just how low it's pointing. Well, why is it pointing so low? Well, just over the top of the dome there, you might see just how low the sun is getting. But I'm just going to open the dome again, so look, you can watch the noise. So we've had some pretty cloudy weather since we've been here on this particular observatory visit to install some new equipment and also just maintain everything else. Look, you can see here we've been working on this big old telescope here. This is the Canary 4 Solar System Telescope. Done lots of work to make some improvements on that. And thankfully, because we have this absolutely glorious day, it's turned into a glorious day here, we are going to be working throughout the night in Dome 3, which houses, actually, I didn't explain that, but we are in Dome 3. I'm in Dome 3. There are 3 telescope systems in here. So we've got there the Canary 4 Solar System Telescope. That's for planets and for small planetary nebula, stuff like that. We've obviously got the Slooh Solar Telescope there. All of this stuff is normally covered in this gold blanket stuff to protect it all from the heat. But underneath here is the other telescope that we're going to be working on tonight. This is the Canary 3 Deep Sky Telescope, and that has a huge field of view and is great for incredibly large galaxies and nebulae and stuff like that. Over there on the hill, you can see one of the largest solar telescopes in the world up there. We've got the VTT, we've got oh, I've forgotten the other name of it, the name of some of the other solar telescopes. Oh, we've got the OGS up there as well. You can see our nearest neighbor is Stella. That kind of long building that you can see up there houses two 2-meter telescopes. But panning round, we've got our lightning conductor again. Our weather station, that's Dome 2. That's going to be online tonight. We have, by the way, for any members who have been keeping an eye on Canary 2, we have already placed the faulty CCD camera shutter. So we're not seeing any street lines on that. So that is really optimized at the moment. We've still got to clean all the optics during this maintenance visit. There is Dome 1 housing the mighty Canary 1 half-meter telescope. We've still got this squatter. We've got to do something about this guy. He's been hanging around with me for the last 4 days, but you'll find out who that is on our 360-degree live tour of the observatory on Saturday. So there it is, the best office space in the world, unless you can prove otherwise. Now, what else have we got coming up? Thank you very much for bearing with us today. It's always difficult doing these things live from the domes, but I hope you've enjoyed it. A little kind of sneak peek behind the scenes of the Slooh Solar Telescope, and to give you a little bit of an update of what we're doing here at the observatory. But we've got some really exciting things coming up. So let me just find my way over my screen. My machine's doing all sorts of odd things on its own today. We have got, as I say, make a day, put this in your diary, because it really will be a great show. It's a first for us. We're using some really, really clever technology to do this. But on Saturday the 12th at, you see the times, 10 a.m. Eastern Standard Time. That's 7 a.m. Sorry for you guys over on the Pacific. So PST. For Europeans, 1500 UTC. That's 3 p.m. in the afternoon for London, Western Europe. So well timed for you. We are going to, me and that squatter that you just saw over there, we're going to be using this special 360-degree live video camera, which means that while you're watching our live cast on Saturday, you'll be able to look at this view like this, and with your mouse, you'll be able to click on the screen and just scroll it around, and you'll be able to look live anywhere you want to point the camera to. So that's going to be quite an exciting one. But then on the 20th January, this is one of the biggest astronomical events in the first quarter of this year. So 20th of January, we have our super blood wolf moon lunar eclipse. It's super because the moon is closer to the Earth than any other time this year, which means it's very, very big. It's blood because it's going to turn, hopefully, a gorgeous red blood color. It's a wolf moon because that is the January full moon. And it's a lunar eclipse. It's a total lunar eclipse, which means it's going to go deep into the Earth's shadow, which is why it turns red. So join me, Dr. Paige Godfrey. We've got special guests coming up on that show as well. Now, unless the studio can tell me otherwise, that wraps up this special show today. It was forecast to be 30 minutes long. I told you, typical Cox style, it was going to go to 40 minutes long. It's actually gone to 55 minutes long. I blame the long commercial breaks, which I actually asked for anyway. But anyway, listen, thank you so much for joining us today. I hope you've enjoyed this little look behind the scenes. We will see you on Saturday. So thank you very much for joining us today. We'll see you tonight with all the live telescope feeds. Bye for now.